In this video, I'm going to explain about the SD-Access components. Actually, I'm going to answer to this question. What is SD-Access? Actually, SD-Access equal to Campus Fabric plus Cisco DNA Center, or the newer name, Cisco Catalyst Center. Don't worry about it now. Actually, the two main components of the Cisco SD-Access are Cisco Campus Fabric that I explained before, include underlay and overlay, and Cisco DNA Center. The Cisco DNA Center or Cisco Catalyst Center offers automation and assurance to create and monitor the Cisco Campus Fabric. You know that in all SDN-based solution, we have two main important components. First, the fabric, and second, the controller. For example, in SD-Access, we have Campus Fabric, and the controller name is DNA Center. In SD-WAN also we have the SD-WAN fabric, and also the controller has, for example, multiple parts include vManage, vSmart, or vBond. About the SD-Access fabric roles and components, we can say the operation of the SD-Access fabric requires multiple different device roles, each with a specific set of responsibilities. Each SD-Access enabled network device must be configured for one or more if you want redundancy of these roles. Okay, during the planning and design phase, it is important to understand the fabric roles and select the most appropriate network device for each role. Let me to explain about these 5 important roles. Look at here: control plane node, fabric border node, fabric edge node, fabric wireless LAN controller or WLC, and intermediate nodes. Here you can see them. As you can see here, we have the traditional campus network include access switches, distribution switches, and also core switches. But we configured the underlay with the layer 3 links, and we enabled a routing protocol like ISIS or OSPF, and now we have the overlay network. Because of that, as you can see now, our access switches are edge or fabric edge devices. Here you can see we have fabric edge nodes. This is one of the important roles in the SDA fabric. And also, you know that we need to have some controller node. Controller node, because you know that in SD-Access fabric in underlay we use Lisp, and in Lisp we have mapping server and mapping resolver. Actually, the control plane node has the same role: mapping server, mapping resolver. And also, if you remember, I explained about the PITR for communicating with external networks. Again, here we have the similar role, the border or fabric border node. The fabric border node is the role that we can use it to communicate with external networks. I will explain it again, don't worry. And also here we have some intermediate nodes. They are for underlay. We use them only for communication, establishing tunnels actually. They are not part of overlay. They are part of underlay. And here we have some fabric wireless controllers. These we can say WLCs can help us for managing the wireless client. Don't worry about detail, I will explain them. And here you can see that we have Cisco DNA Center. This is our controller and the place that we work with it for many functions of the Cisco SD-Access, for provisioning, for automation, for configuration, for maintenance, and also troubleshooting. And also we use Cisco ISE. With Cisco ISE, we authenticate our users' wired or wireless clients and also devices. And after that, we can assign tags to the traffic of them from Cisco ISE, and this is the actually policy plane of the Cisco SDA with the help of these tags, or actually the tags that I explained before, scalable group tags, we can control the communication inside the SDA fabric. As a review for now, because this is the first video that we encounter with the SDAccess components, let me to review these roles again. First, control plane node. This node. This node contains the setting, protocols, and mapping tables to provide the endpoint to location, means EID to RLOOK mapping system for the fabric overlay. And you can easily understand the function of this. Why? Because this is the Lisp mapping server or mapping resolver. But here we don't say Lisp mapping server. We say the SDA control plane node. And in configuration, also you will see this actually role. It means that when we configure SDAccess, I will show you in future videos, you will assign a role to one or more than one device as control plane node. You will see this with CP. CP means control plane node. The next actually role is fabric border. Here we have two fabric border nodes. Okay, these fabric devices, for example, core layer device in our scenario, connects external layer 3 networks to the SDA fabric, as you can see here. This is like the PXTR. Actually, they are PXTR or PTR, PITR in the Lisp terminology. After that, fabric edge node. These fabric devices, for example, access or in some cases distribution layer devices, connect wired endpoint to the SDA fabric. Okay, here you can see we have multiple edge nodes. About the fabric wireless LAN controller or WLC, these fabric device connect APs, means access points, and wireless endpoints to the SDA fabric. Here we have some explanations that we will learn about them in future. And finally, intermediate devices, okay, these devices or intermediate nodes, these intermediate routers or extended switches, multi-layer switch, do not provide any sort of SDAccess fabric role other than underlaid actually services. This figure can show us the different SDAccess fabric design roles and how nodes in the fabric can play multiple roles. For example, here as you can see, the core layer switches, okay, or core layer routers are acting as fabric border node and control plane nodes. As you can see, here we have fabric border node, fabric control plane node, and they are fabric intermediate nodes. Don't forget, it is possible to, for example, implement one or more than one role in one device. For example, you can configure both of these two core layer switches as fabric border node and also fabric actually control plane node. It is possible for redundancy. Or if you want, you can dedicate one device for fabric border node and one other device for fabric control plane node. And here, as you can see in this design, the distribution layer switches are configured as fabric intermediate nodes. And also here we have fabric edge nodes. Also, we have some services and we have some actually features that we need them in Cisco SD-Access. For example, we need the Cisco DNA Center as the controller. We need Cisco ICE as the control plane or actually policy plane component, and also the authentication server, and also wireless LAN controller for provisioning and actually controlling the wireless clients and also the APs access points, and maybe some other network services like DHCP, like DNS, like NTP, okay, and other type of services. Actually, here we have the wired endpoints and users, and they can connect to our SD-Access Fabric with the help of fabric edge node, fabric control plane node, fabric border node, and also the controller means DNA center, ICE, wireless LAN controller. Now, let me to explain with more detail about them. But you know that in each step, we can understand some part of the fact. Actually, now I'm trying to give you more information, but not all information, because it is easier to understand each feature step by step. As a start point, let me to start with Fabric Edge nodes. About the Fabric Edge node, you know that this Fabric Edge node provide us for the now the wired client connectivity. Okay, actually a Fabric Edge node provides onboarding and mobility service for wired users and devices, okay, including Fabric enabled wireless LAN controllers and APs, because you know that AP should connect to the Fabric Edge node, okay. And you know that it is a Lisp tunnel router XTR. I explained it before. You know that in underlay we use Lisp, and this is the actually Lisp edge node. And in Lisp, you know that we say ITR or X or ETR, or if one device provide both function, XTR. Okay, it is a Lisp tunnel router or XTR that also provides the Anycast gateway. Anycast gateway is an interesting feature. What does it mean? Briefly, let me to explain that. You have one IP, you know that here we have layer 3 links, okay? Assume that the IP1 is the gateway of one PC. IP1 is the IP address of, for example, SVI interface, means interface VLAN 2, the PC connected to VLAN 2, and the IP address of the interface VLAN 2 in this device is IP1. With Anycast gateway, you can use the same IP address, okay, the same IP address on all switches as the gateway of your computer. Actually, you know that it is not possible in traditional networks. Actually, when you move from one device to other device, okay, one edge node to other edge node, you need to change the gateway. And because of that, all sessions will tear down, and you know that this is not good for communication. Again, communication should establish, sessions should establish. But with the help of this feature, Anycast gateway, the IP address is same in all switch, the gateway IP address. What does it mean? When you roam, when you move from first switch to the next switch, you don't change your gateway. Actually, from the view of the computers connected to the edge nodes, we have a large virtual switch. And this large virtual switch provides us one IP address as the gateway. Okay, because of that, this is one of the benefits of the, for example, implementing the layer 3 links and also the Lisp in underlay. And the next actually feature that tunnel XTR actually can provide us is endpoint authentication. Actually, you know that when we connect to the Fabric Edge node, here we have authentication. I will explain it in future with the help of Cisco ICE. And finally, we authenticate the users. And also we assign the users the SGT tag received from the ICE, and also some other useful information like DHCP received, IP addressing, other information. We forward them to the for example, wired clients. Okay, actually we can say a Lisp tunnel router provide Anycast gateway, endpoint authentication, and assignment to overlay host pools statically or with DHCP, as well as group-based policy enforcement for traffic to Fabric endpoints. You will learn about them. It means that all traffic received, for example, from this PC will tag with the tag received from the ICE, and after that, according to the tag that we assign to the traffic in the VXLAN header, other devices can use some specific type of ACLs to control this traffic, where this traffic can go and where it cannot go. Okay, and actually a fabric edge, these devices first identifies and authenticates wired endpoint through 802.1x. Here we have some details, but let me to inform you that one PC or one laptop connect to the edge node. Okay, first it should authenticate the PC with Cisco ISE. After authentication, that here we have some details. Don't forget the process is happened with IEEE 802.1x. Okay, this is the authenticator. The edge node is authenticator, and after that, after authentication, the edge node can place the host in a pool. Means actually according to the VRF and according to the SVI, it will assign the PC, it will give the PC IP address and also other useful information. And also if from ISE we receive the policy or SGT, the edge should attach to the traffic of actually PC that is receiving in the edge the tag. For example, here we receive from the PC pure traffic, and when we encapsulate this traffic in VXLAN header, we will assign the SGT tag, and other devices will use this SGT tag. Okay, and also the edge, as you know, because this is the XTR, should register the specific EID host address, that is MAC address /32 IPv4 or /128 IPv6 with the control plane node. You know that we are talking about the Lisp. What does it mean? The computer connect to the edge node. After authentication, the actually edge node should register this EID in the control plane node. And also, if a traffic received from this PC, the traffic should be tagged according to the policy received from the actually ISE. A fabric edge first identifies and authenticates wired client through 802.1x in order to place them in a host pool, means SVI and VRF instance, and a scalable group, means SGT assignment or a scalable group tag. It then registers the specific EID host address with the control plane node. And a fabric edge provides a single layer 3 Anycast gateway that, as I explained before, that is the same switch virtual interface with the same IP address on all fabric edge node for its connected endpoints, and also performs the encapsulation and de-encapsulation of host traffic to and from its connected endpoints. You know that this is XTR. Okay, and also let me to inform you that an edge node must be either a Cisco switch or router operating in the fabric overlay. And again, let me to emphasize that we will learn more than this about all of these functions. Now we started learning about the Cisco SD-Access components. All right, this is the fabric edge node. Now about the fabric control plane node, you know that this is like the Lisp mapping server and mapping resolver. Actually, a fabric control plane node is a Lisp map server, resolver, or MR, but with enhanced function for SD-Access, such as fabric wireless and SGT mapping. You know that here we have a scalable group tag. In the SD-Access fabric, we use SGT for actually policy plane. Okay, but in Lisp we don't have SGT. Because of that, if you have SGT in mapping server, we need to have to actually keep SGTs. Because of that, here we have some more functionalities or enhanced functionality of the more than mapping server, mapping resolver in Lisp. This is fabric control plane node. Actually, this is the MSMR of Lisp with enhanced functions, such as fabric wireless also and SGT mapping. It maintains a simple host tracking database, okay, we call it HTDB, to map EIDs to RLOOK. And you have learned about it only for better understanding. You know that it is useful. You know that each host has an EID. For example, this host has EID 1. Okay. And now it is connected to this switch. Okay. And because of that, the RLOOK or the IP address of this switch is RLOOK 1. Now, in the control plane node, this control plane node, we have this mapping. EID 1 now is a reside in the RLOOK 1. If you want to reach to EID 1, you can use RLOOK 1. Assume that EID 1 roam or move to the other switch, for example, this switch. Okay. And actually, now the RLOOK changed to the RLOOK, for example, 4. And you know that this device, this edge device should inform to the SDAccess actually fabric control plane node that now EID 1 can reach from the RLOOK 4. What does it mean? Actually, here we have a host tracking database. We call it HTDB, host tracking database. It maintains a simple host tracking database to map EIDs and RLOOKs. Yes, this is the Lisp mapping server and mapping resolver with enhanced functionality. Until now, we didn't see enhanced functionality. This is exactly the Lisp function, Lisp mapping server, mapping resolver actually function. And the control plane or host database maps all EID locations to the current fabric edge or border node. And it is capable of multiple EID lookup types, means with IPv4, with IPv6, with MAC. Okay. The control plane receives registration from fabric edge or border node. Border node for external communication. Okay. Don't worry about it now. For non-EIDs and actually non-EID prefixes from wired endpoint and from fabric mode wireless LAN controller for wireless clients. I will explain, but for now, let me to inform you that fabric edge node should inform to the fabric control plane node about wired clients. And also, the fabric wireless LAN controller should inform to the control plane node about wireless clients. Actually, you can assume that wireless LAN controller is the edge node for the wireless clients. Okay. Because of that, here we have two types of information or two actually register type message, one from edge node, fabric edge node, and other from the fabric wireless LAN controller. It also resolves, because this is MR also, it also resolves lookup request from fabric edge or border node to locate destination EIDs and updates fabric edge nodes and border node with wired and wireless client mobility and RLOOK information. Why we can understand these concepts? Because we know about the Lisp. If here you need to review some of the concepts, I recommend you again watch the video about the Lisp, because I explain all of these functions in that video. Control plane devices must maintain all endpoint and host mapping in a fabric. A device with sufficient hardware and software scale for the fabric must be selected for this function. And also, a control plane node, okay, must be either a Cisco switch or a router operating either inside or outside the SDAccess fabric. In most cases, we have it here, we have it inside the SDAccess fabric. All right, about the next role, fabric border node. You know that this is the PETR or PITR, means PXTR, for communication with outside of the network. Here we have some details, and some of these details a little changed in newer versions of Cisco DNA Center. But let me to inform you that about the fabric border node, we have three types of fabric border node. First, internal border. Okay. Second, default border. Third, okay, and third, internal plus default. Internal plus default router. Okay. And maybe some of these details are a little more than the scope of this video, but it is useful for the first time to hear about them, and maybe in future we can understand them a little better. First, about the Fabric border node. What is the Fabric border node? Yes, Fabric border nodes are least proxy tunnel routers or PXTR that connect external layer 3 network to the SDAccess Fabric and translates reachability and policy information, such as VRF and SGT information from one domain to another. There are three types of border nodes. Internal border. Actually, this internal border connects only to the known areas of the organization. What does it mean? This, you know that we use this Fabric border node for communication between the SDAccess Fabric and the external networks. But this external network can be internet or can be other parts of our company. For example, the place that DNA Center, ICE, Wireless LAN Controller, Active Directory, DNS server, and other services are available. Actually, when we connect the Fabric border node for connecting to rest of our company, this is internal border. But default border means we connect this border for the actually connecting to the internet. It means that in default border, we connect only to unknown areas outside the organization. This border node is configured with a default route to reach external unknown networks such as the internet or the public cloud that are known to the control plane nodes. And finally, I think you can understand it easily. What is the internal plus default rule? Default border means anywhere. It connects transit, actually this connects transit areas as well as known areas of the company. This is basically a border that combines internal and default border functionality into a single node. Because of that, internal border means connect the Fabric to the rest of company. Default border connect to the outside of our company. Internal plus default means connect us to anywhere. All right, the next component is Fabric Wireless LAN Controller or WLAN Controller. Actually, we use a wireless LAN controller for the wireless clients and also APs. And you know that this is like the edge node for the wired clients. About the wireless LAN controller, because I want to give you first some knowledge about the traditional function of wireless LAN controller and its change in the Cisco SD-Access structure. Let me to explain it in the next video. Actually, first I will explain you about the function of wireless LAN controller in traditional LANs, okay? About the control plane and data plane tunnels between the APs and wireless LAN controller, how it is happening in traditional actually implementation of LAN, and what is changed in the Cisco SD-Access. Actually, you will see as a brief review that in actually traditional LAN, we have control plane tunnel and data plane tunnel between the AP and wireless LAN controller. But here we have only control plane tunnel. For better understanding of everything, we need to compare the differences in different places. It can give us good insight about the different functions, why this is changed, what are the benefits, and actually it can give you a high-level view about all of these technologies. Then you can think like a master. For example, you say, yes, in traditional LAN, we use wireless LAN controller with these features, but because in Cisco SD-Access, we need to implement other functions, other actually qualities, we need to use wireless LAN controller a little with different approach. Okay, it can give you good insight. Because of that, let me to explain about the Fabric wireless controller and also the wireless LAN controller in traditional LAN in the next video.